Hi guys, welcome to my YouTube channel, and in this video I will briefly discuss about electric potential. In order to understand the electric potential, I will draw two parallel plates in which one plate has a positive charge, equally distributed positive charge, and other plate will have a negative charge which will be equally distributed. So in this case, negative charge is placing in the other plate, and we see that the principle of electric field intensity or electric field lines is that electric field lines start from positive terminal of the plate and end at a negative terminal, and the arrow the sign show the orientation or direction of the electric field lines between the parallel plates. So this can also be used as a capacitor or but the difference is that there is a big gap between these two plates, and in capacitor there is a very little gap between these two plates. So we will place a positive charge, or which will be test charge or point charge, which will be placed in the between these two lines, and naturally this positive test charge or point charge will point or move towards the negative. Because of its opposite sign, the positive point charge will move towards the negative plate. So it is a natural process, and if we want to move this point charge of positive point charge towards the positive plate, or the plate which is a sign is equal sign, or they will repel each other. So in order to do this, or in order to move this charge, we will need to apply some force, and this force should be in such a way that this charge should move in equilibrium towards the positive plate. So this force is equal to Q naught into E, which will be the Coulomb force between these two plates, and the electric field lines is a multiplication with the, or this is a product of charge with the electric field lines, which is known as a force. And in order to further understand this force, or work is being done in order to move opposite direction of the positive charge towards the positive plate, the work is done. This work is in the form of change in their potential energy. So when the particle is moving towards the negative plate, it has a kinetic energy, a stored kinetic energy, and if we want to move this particle towards the positive plate, we need to store a potential energy. And when we open, or when we replace this, or when we release this, the positive charge or point charge will move towards the negative plate. So in this case we define that one is known as B charge and other is known as A plate. The names of the plates are known, and the voltage or potential will be in the form of work done from A to B is equal to work done in the change in potential or change in potential energy, UB minus UA will be in the form of this, and over Q the charge will be there. In order to further understand this work done is against the kinetic energy, and which will be in the form of stored potential energy of that point charge. So delta V should be in the form of VB VA minus V. So the change of potential VA minus VB will in the form of work done by a charge, or work done on a unit positive charge or point charge. So VA minus VB is equal to work done from point A to point B over Q naught. So this is a expression for change in potential between these two parallel plates when a point charge is placed between these two plates. And naturally this positive point charge will move downward towards the negative plate, but our purpose is to find out its potential energy or its potential. So this potential will be in the form of work done when we apply some force. In order to move this point charge towards the positive plate, we will need to apply some force, or we will need to do some work. So change in potential is equal to change in work done or change in potential over Q naught, because this work done or this change in potential will be in the form will be on the point charge. So per unit charge is a change in potential. So delta U is equal to Q naught into delta V, we will replace the value of Q naught to the other side of the equation. So delta U, or change in potential, is equal to Q naught into delta V. So change in potential from point B to point A, because we are moving the charge from B plate to the A plate, so it will be in the form of work done from A to B over Q naught. So this is the final expression, and if we talk about its units, so its units can be in the form of voltage or work done between these 2 points, or work done between these 2 plates on a positive point charge or test charge. So this voltage or change in volt has some units. If we replace the value of delta U, so delta V has a unit of volts, 1 volt, and the delta U is a work done which has a unit of joule, and Q is a charge of having coulomb. So 1 volt is equal to 1 joule of work done on a unit positive charge having a unit of 1 coulomb. So this is a unit of 1 volt with respect to work done on a unit positive charge. So up till now we have discussed about electric potential, and we have drawn 2 parallel plates in which one plate is a positive charge and other place is a negative charge, and we have drawn the electric field lines. The direction is shown here, as well as if we place a positive charge between these 2 lines, so it will move towards downward towards the negative plate, but we need to calculate its potential. We will apply some force, and we have done a lot of experiments and a lot of calculations here. If you have any question, you can contact me at my email address, or you can WhatsApp me at this number, or if you have any question, please write in a comment box. Thank you so much.